So here's a few notes on energy in the Pacific Northwest. Most of what I'm going to present here will be notes that I won't have posted online, so you can kind of just use this as you would if you were in a classroom setting and the instructor was putting notes up on the board or something, and then you would write them down. So, or you screenshot them, whatever you're into. Writing down probably helps you learn it a little better, or maybe you want to do a little bit of both. I don't know. It's up to you, of course. But just to let you know, you won't be getting an outline of this. Some of the supporting materials here, though, I will provide. So just to let you know that. All right. So let's have a look. We're going to look at four kind of big questions here, and then lots of things that connect with those. So the first one is, what are the sources of energy for and in the Pacific Northwest? So we're talking about when we use the term energy, there's all sorts of energy. So we'll make that a little clearer later on exactly what we mean by that. What are the uses, pros and cons? Excuse me, I'm going to read that again. What are the uses, the pros, and the cons of each source? Okay, so there's always trade-offs, almost always trade-offs in energy, and we'll look at that. What is the outlook, number 3, for non-hydro renewables? And then finally, what are the current and future roles of the Pacific Northwest in the North American energy economy? And by extension, a little bit we'll extend that out beyond the North American energy economy. But for the most part, that's what we're going to focus on. So a few concepts so that we can talk in the same language and understand each other about energy. One is fossil fuels. What are fossil fuels? They are, I'll just give you the three main ones, coal, oil, and natural gas. And you might recall just a tiny bit that we looked at the kind of places that they form, but basically in old shallow sea beds, in swamps, and so on, over very, very long periods of time, in millions of years. That's the term fossil, okay? Now, fossil fuels, as you know, when you combust them, there's pollution. So we're going to look at some questions related to that. And of course, their combustion in producing carbon dioxide changes our climate, and that's one of the big topics, of course. Solar-based energy sources are another. What do we mean by solar-based? This is where you want to take a few extra notes, okay? Don't go on yet to the next line because I'm going to give you several things to write here. Solar-based, one type of solar-based energy source would be solar heating. So you could have, say, a solar water heater on the roof of the home you live in, and the sun shines on that heater and warms up the water a little bit or a lot, depending on time of year. Even in the winter, though, even when the sun is not very abundant, it can warm up the water some, and then it needs to be warmed up less as it goes through a hot water heater inside the house. That would be one kind. Another kind of solar heating concept would be what we call passive solar design for a home or another kind of building. And again, it's the sun warming it up. Now, when I said solar-based, you were probably thinking about solar panels. And in fact, solar panels are one way to warm up hot water. You put the water in kind of big containers, kind of like panels. But of course, when we talk about solar energy, most people think first about solar photovoltaic, PHOTOVOLTAIC. By the way, I will try to go slowly enough that you can mostly write this down, but you might want to stop once in a while too, because I don't want to spend too much time on any given one of these for those of you who want to go through it quickly and review later. So solar photovoltaic, that's when we make electricity with solar panels. And that's really a big thing in the past decade. Got some really exciting stuff to share with you on that. So a third type of solar-based energy source is wind. Now, you didn't think I was going to say that probably, but what solar-based in this case means is that ultimately something about the effects of the sun are used in one way or another to harness energy, to make energy or harness energy. And so in the case of wind, it's the global wind systems are driven by differences in solar radiative heating on one hand and the lack thereof and another. So for example, in polar areas during their winters, it's very cold, and the air flows out of those areas for the most part into warmer areas. And so the global wind system is to a large degree based on differences in solar heating and cooling. So wind is one, okay? Another, since the winds blow over the waters and then they go over the land and there's precipitation in both places, also hydroelectricity is a solar-based energy source. Yeah, okay, so hydro. Another is, well, if the wind blows on the water and the water moves up and down, we call those waves, and also horizontally, then if we can harness that up and down, that kinetic energy delivered by those waves and make some kind of electricity out of it, then that would be yet another kind, so a wave. And then finally, if we use the sun to grow something, then use that as fuels. It's like, for example, ethanol that you use in your automobile if you have one, or a little bit of biofuel in the diesel, biodiesel in your diesel if you drive a diesel vehicle. Those would be also solar-based because the sun provides the energy that drives the photosynthesis, and later we make that into some kind of useful energy. Okay. Now, there are other renewable energy sources besides those just above. Okay, so in a sense, you could say solar-based energy sources are renewable in the sense that they can be used indefinitely because the sun keeps on shining, at least when it's out. Okay, but another kind of renewable energy source is one that's not solar, and the most useful one for us is geothermal, where, for example, in Klamath Falls, some buildings are heated from that. There's a big plant in Northern California which provides what they call baseload electricity, so it generates electricity through its heating. So that would be an example of a renewable energy source. What about nuclear? It's not technically renewable, but there is a lot of nuclear fissile material in the world, but it's not generally considered renewable, but it's not a fossil fuel either up above, okay? Now, a couple concepts. One is stocks. When we think, that doesn't mean stocks as in, oh, I bought GM stock and it went up. What we're talking about is stocks in the world of energy, which are basically stored and then are made available when needed. So a coal-fired electricity plant would have a pile of coal nearby, several perhaps, stored away. Some maybe even on rail cars coming in, and then it's used as needed. That would be a stock, okay? Gasoline or diesel tanks or petroleum tanks from which the gasoline and diesel are refined. That would be stocks, okay? How about water behind a dam that has turbines in it that can make electricity? That's also a stock, okay? Now that's not a fuel in the same sense, but it's definitely used to generate a usable kind of power. We call that hydropower. Okay, so that would be a kind of stock. So now, if you're not sure where we're going with that, let's contrast that with flows. If my solar panels on my roof today are generating electricity, there must be some sun. So there's a flow of energy from the sun, basically power that the photovoltaic panels can transform into electricity, in other words, moving electrons. And so that would be a kind of flow. Or the wind turbines in the Columbia River Gorge are harnessing flows of wind. So it's something that goes on and it goes off. And we don't necessarily even have full control over that. That's more of a flow. Which are more useful? Well, in some ways, we could say stocks are more useful because we can use them just exactly as needed. Whereas in the case of the sun or the wind, there is either night, in the case of the sun, or clouds, too many of them, to produce a lot of electricity, or the wind also blows and sometimes it doesn't blow, or blows a lot or a little, this sort of thing, okay? So flows and stocks, different kinds of energy to think about. And we're going to later look at that in some detail, okay? So a quick look, okay, the United States, just to give you a perspective before we go into the Pacific Northwest, our energy utilization. This is a 2019 year data, and just to give you a sense of the primary energy consumption. What we mean by that is, like, if we're going to use coal to make electricity, which most coal does go into electricity use, not all, or go into electricity generation. Coal would be the primary energy. The amount of electricity produced is much less, somewhere in the order typically of maybe 30 or 40% of all of the energy in the coal actually gets into form of electricity. So there's a loss there. There's also a loss there in the nuclear electric power. The fissile available energy is less than the electricity energy produced, okay? Natural gas, same kind of thing, okay? Petroleum, same kind of thing. The energy in your car is not the energy that's actually driving it. The energy in the gasoline, it's much, much less than that, the actual energy that's useful energy. So this is just kind of those big numbers, what we start with, and then we have huge losses. And that's always the case when you have fuels, by the way. Thermal or heat engines are by their nature very inefficient. Almost never more than about 40% efficient would be kind of tops. My car probably is 23% or so of the energy, and the gasoline actually becomes kinetic energy, okay? Now, that said, let's have a look. So really, if you just look at the kind of big three sources, typically coal, petroleum, natural gas, the big three fossil fuels, that is, they're a big part of the whole story, aren't they, in the United States? Renewables are about the same. All the renewable energy is roughly the same as coal. Not exactly a fair comparison, though, because when you have solar or wind energy, which is basically electricity, the way we think of it for the most part, that electricity is much more efficient. You can use electricity into an electric vehicle. Might be a system that's 75, 80, or even more % efficient, whereas the gasoline that comes from petroleum that's used in an internal combustion engine in a car, as I said, might be at best 25% efficient, something like that. So not entirely useful comparison to look at this, say, versus coal, because we actually get more useful energy out of renewables, but nonetheless, it gives us at least a benchmark, okay? Now with renewables, nationally, this is interesting. Hydro, 22% of our renewable energy in the United States comes from hydro. And interestingly, this is a recent thing, wind. I'll bet you didn't know this one. Okay, most people don't. I wouldn't have known it unless I happened to do this kind of stuff for my work. But 24% now of renewable energy is from wind, okay? And interestingly, if you take the biomass in our fuel economy, particularly, biofuels, ethanol, and a little bit of biodiesel, these two are less than wind. So interesting, we're producing more energy with wind than we are with biofuels in this particular case, okay? And also more than hydroelectricity. So wind energy is a big player. Kind of a neat story if you're a fan of that sort of thing. Okay, so let's look at the next chart, and actually let's stop here. We'll go to the next chart and the next one. Okay, not enough time to do it well.